last week, the new MCP protocol dropped, and we started really digging into it. We knew a lot of it was coming. We really dug into a lot of how it was being implemented, and there's some really interesting stuff in there. And
some of it was snuck in like last minute.
Some of it was snuck in. Some of it changed. Some of it did not make it. Some of it really shocked us positively and negatively, and some of it for me I thought was going to be extremely boring, and then like broke my brain. And I called you about it yesterday and got all excited. And we should talk about that too. But why don't we? You've been staring at this for longer than I have. You called me 2 months ago, 3 months ago, something like that, right? And you go, there's going to be background tasks in MCP. This changes everything. I want to dedicate everything to this. So like, let's start there.
Okay. So, I mean, the why behind a lot of the stuff is twofold. One is like, people always ask a lot of like, what's the master plan of like Prefect and FastMCP? Why'd you guys build it? And a lot of the time we have to like manufacture a story, when the real story is like, we just get nerd sniped by pieces of technology that come out a lot. And there's probably some like thing in our brain of just like, we've been building agent frameworks for so long that, and we know what's hard about them, and we know many of the reasons why they succeed and fail. And it feels like a lot of the reasons why agent frameworks fail are not quite getting the ergonomics on tools done correctly. And it tends to mean that like, if you're trying to have an organization try to build agents internally, it means that the only people who can use tools are what? Like people who can use software internally. And so I guess the point that I'm trying to say is like the fact that you could define tools internally and then share them, I think was very interesting to us as folks that have like built agent frameworks and then saw what it looked like for folks in an organization to adopt them. So where am I going with this? So like, I think that's the reason why we got interested in FastMCP in the first place, not truly because there was like some master plan of like orchestration and MCP marrying up together. I think that's like, they tend to be two branches of the like civilization tech tree of making sure data is available and ready. And then the other one is like, hey, this is how people are going to consume these things.
Well, there was a clear question that MCP might have been the answer to, which is in an LLM-driven world, which you and I believe we're entering for years now. Yeah. In an LLM-driven world, what is the role of orchestration? What are you orchestrating? And MCP seemed like a key part of that story, even if we didn't know what it was at the time.
Yeah. So I guess if you fast forward to when I first saw tasks, I thought two things, which is one, this is actually great for the adoption of MCP, because I think a lot of people, you know, I've talked about this before, like when you designed agents, you had to co-locate your tools to your actual agents, which meant that agents who are responsible for planning and holding state were exposed to the risk of their tools failing. You can try and isolate them in separate processes, but if the machine itself crashes because it tried to take on too much risk, now you've crashed your orchestrator, which is a bad thing. And so MCP was great. I think a lot of people were excited because it meant identity-aware, stateful conversations over time. But I really liked it from a point of view of there's good separation of concerns. You get to put the scary stuff on the server, and your agent client side gets to be very lightweight, and it is really manifestly responsible for managing its own context window. And but it meant that if you wanted to do big, heavy tool calls, it was very scary to do that server side because you'd have to hold open a connection for the entire duration of your tool call. And so people ended up doing a few things. They would move the big, heavy, scary thing client side, which undermined the entire promise of MCP to begin with, where everybody started inventing their own client orchestra or their own task orchestration on the server. You would have every tool return with a promise. You would have just a bunch of different routes that were dedicated towards checking up on stuff. People named them all differently. And then the client didn't have a polling mechanism. So, you know, if you were in Claude AI, you would have to keep asking, like, is my task done? Is my task done? Are we there yet? And so I saw SEP 1686. I think it had a different number at the time because it had a different design. As really delivering on the promise of being able to have like long running tasks, being able to actually execute without having to bear the risk of a long running network connection. It also meant that you can now have agents truly live on an MCP server. So you can have server side agents that client side agents can connect to. That was like one of the chief things of having long running operations. And I think, I mean, we've been building a task and workflow orchestrator for years. And so I think that we've just seen that it can often feel like we're close to we're on the better side of a decade of understanding all the scary stuff and all the nuance of doing orchestrating like long running stuff. And so when I saw them taking this seriously as a concern, I was like, this is great. This leans into a lot of our expertise.
Well, I think you were way ahead of the curve on this one. When you first started telling me about this, I pushed back.
Oh yeah,
this is not a big deal. This is a waste of your time, right? Because I think to give you some credit, right? You were referring to this as background tasks from day one.
Yeah,
but that is new in the spec. When we started talking about this, I think it was called Async tool calls. I think was the headline of it.
Yeah,
and you were full steam ahead. This is background tasks. This changes how the agents are going to work, change how a lot of things are going to work. And I remember being like, no, we can already do this. I don't get this.
sure.
For all the kludgy regions you said. I don't like it's not even async on the server. The server can still be sync. It's just async from the cloud. Like I had all these excuses for it. And then I think that the SEP caught up to where you were and like made possible what you always were declaring it was, and I shouldn't say made possible, made explicit what you were is declaring it was. And so now we have like background tasks that are intended for long running, potentially agentic processes with, it is that. And it's interesting. It did not start there. And I was a skeptic when we first saw the proposal.
SEPC, and what's funny about that is like, there was a flux between when we first heard about it. Because I think when you were at the MCP maintainers meeting, this is when the working group got started, like in August or something like this.
Yeah, I joined the first meeting or one of the first meetings of that group, and I was on the side of the table being like, we can already do this. I don't get it.
Yeah. Because I mean, I think it was, when you hear async, depending on what flavor of engineer you are, you're like, well, I can run Python functions async. Like you're thinking about it through the NEIO style. And then there is the task orchestrator async, like I can finally background task stuff and not have to think about it. But it's funny, SEP 1686 almost died a few times. I mentioned that it had a completely different number at the end of it. It was pretty hotly debated in the MCP maintainers Discord for a while, and just went through a ton of different iterations of like, basically, you can go invoke a tool call, and the client can dictate whether or not it's going to be async or sync or something like this. You don't have to negotiate its capabilities up front. There was a bunch of discussions of how to actually make it backwards compatible, whether or not it was going to be sent in the meta or something like this. There were folks that were like, do we even need a new protocol for this at all? Like, can I just return like a,
yeah, that was
what's the status code 204 with a location or something? Like there's some HTTP mechanics for giving somebody the location of a thing to go check. And so
there was another guy who was in this meeting who's Sean from Hugging Face, and he and I think at the time we declared that we were MCP maximalists, and we saw no need for a new part of the protocol to enable something that we thought MCP could already do. I'm happy to be wrong, right? Like I think that what the current implementation is so cool, and what we're shipping into it is extremely cool. Can we talk about that for a second? Because we are taking the open source, the newly open source, like beating heart of Prefect Cloud, and making it available to everyone to make this as awesome as possible.
Oh yeah. So let me give some background on this. So for MCP now supports tasks, which now means that your server has to be able to handle background tasks, which means that your server has to keep track of state, of a bunch of different stuff, and it has to be able to like hold on to the results, understand where they are on the state machine, so that people can go check up on the results later. And so when we were shipping FastMCP with background tasks, our big thing was, well, why do people choose FastMCP to begin with? We've been super deliberate at making sure that, you know, if somebody's just trying to get auth to work, they shouldn't have to go become an auth expert. If somebody's just trying to get middleware to work, they shouldn't have to go become some middleware expert. So really trying to like make sure that FastMCP ships with really intuitive, really intuitive, high-level interfaces, so that you can do really powerful stuff. You can eject out of it and go do the very complex stuff yourself, but the entry point for it should be straightforward for folks to work with. And we want to do the same thing with tasks. And so, you know, there's a bunch of task orchestration libraries out there in the world. A lot of them didn't quite have the throughput. A lot of them had a lot of assumptions that were around like long-running, like workflow orchestration-y stuff that we didn't really want to bundle into FastMCP. And so what we did is we took the core background task engine that we use for Prefect Cloud. So Prefect Cloud, at its highest, I think we orchestrate like 100 million tasks a minute at peak. We orchestrate 1.5 million of compute every month, and those are just like tasks, and every task makes, you know, a handful of network calls. So like we're doing like billions of background tasks in our core enterprise product every single month. And we built a background task engine in order to handle those billions of background tasks. And so this is like a proven solution that like tens of thousands of our customers implicitly depend on every single day. And so when we were shopping around for like, what's the best interface? What's like the most ergonomic thing for us to ship to folks? We wanted to ship them something that we knew worked. And so, so we took our background task engine that we use at Prefect. It's called Pydocket. And we open sourced it, and that's shipping with FastMCP. So for folks that are trying to use background tasks with FastMCP, you literally have a ergonomic, very simple to use, very powerful, scales to enterprise when you need it, background task orchestrator built on Redis streams. You don't need Redis on day one to use it effectively. It ships with an in-memory broker, but it allows for an actual distributed task engine when you're ready for it. We've made it super portable. You can plug in your favorite task orchestrator if you want, but it's shipping with the one that we know actually delivers results on day one.
Yeah, I'm extremely excited about that. We just we've been teeing up those PRs for close to a month now. We just merged the big one last night because we want this to go out next week with the next major version of FastMCP as we start to roll out all the new spec update stuff. So I mean, very brave folks can try it as we're recording this, but most folks will see it very soon, which is super exciting.
All right. So I've talked a lot about tasks, and I talked a bit about tasks allowing sub-agents on the server. But you and I were talking yesterday about one of the other sleeper SEPs, which basically allows the server to send a sub-agent to the client, if that's the right way of putting it. You put out a blog post yesterday called The Inverted Agent. Do you want to talk about SEP 1577?
I do. SEP 1577 is all I want to talk about, actually. It has like broken my brain in a really interesting way, in a way that shocked me. So I thought this was going to be like the most boring of the updates. So there's a feature in MCP. It's called sampling. Last spring, when we were building out FastMCP 2, there were a number of features that I thought were just killer and cool. And if only more people could access them easily, people would know how great MCP is. And sampling was one of them. And the idea of sampling is your MCP server, despite being part of the agentic stack, there's no LLM involved in your MCP server. It's like a programmatic interface that agents interact with, but it's not agentic itself. But what if you need to do something using an LLM on the server? And the answer is this sampling feature where instead, well, a developer can obviously just call an LLM from the server. That's no problem. But what sampling lets you do is it actually lets you ask the MCP client to run their LLM on a prompt and then send the answer back to you. And it like lets you borrow your client's LLM temporarily. And I just, this was super cool. I thought it enabled really interesting use cases and stuff like that. It turned out to be a little bit limited because the only thing you could get back, the only thing the spec lets you get back was text, a string of text. And in this MCP server that's not itself agentic, getting text back isn't the most useful thing. Like you can't even ask, to make a choice of things because you aren't guaranteed you're going to get back a programmatic or a data structure that you can work with. It's just text. It could be anything. And so it ended up being, I think, of sort of limited utility. The person who loved it more than anyone else was Bill Easton, who's one of our FastMCP maintainers. Bill took this thing to the max. He convinced it to, he invented a DSL. So through sampling, you could make tool calls, you could return structured data. He built like this whole agent framework on top of it. And finally, SEP 1577 has caught up to Bill and is making all of that first class in the spec. And so why this is so interesting to me is not just because now you can ask your client LLM to call a tool or process something or do it in an interesting way. It's because it completely inverts how you think about an agent in a way that I literally had to stop. I think I called you from the car. I was like, I need to talk about this with someone because it's so fascinating to me. For the last 3 years, if you wanted to run an agent, you wrote a Python script. And the Python script had the agent library and all the things you wanted to do and the tool definitions and all that stuff. And you called out to an LLM that lived on a server somewhere to do the actual runtime processing of the natural language stuff. And then you brought that back in your script for the control flow. And now all of a sudden we have a way to do all of that agent orchestration on the server. And every single client who connects to it sort of takes on the role of actually doing the agent processing. And so the distribution model is completely backwards now. Well, like there are entire companies dedicated to like agent distribution and agent deployment and agent monitoring because it's hard to get those Python scripts that have your agent in them to run anywhere and be observed and do the right thing. And now all of a sudden we have a way where it's like this MCP server is all of that in one place. You don't need to distribute it at all. You just need to run your server. And now every client that connects to it automatically benefits and participates in that agentic workflow. I think that's wild. The fact that you could change an entire ecosystem like that, now this requires adoption, this requires client support. It's not an overnight change, but I would not have even bet that what we're talking about here is possible, that you could have a centralized agent orchestrator and portable LLMs as opposed to many different agent implementations and one centralized LLM server. That broke my brain. I don't know. Maybe it's just me and Bill now. We're the only two people who care about this.
I just have this exhibit meme in my head of like, yo dog, I heard you like tools, so I put tools in your MCP server to put tools in your tools. Like because you can now sample back over to the client with a list of tools, and those tools can be from another MCP server. So like I'm fascinated by this idea of like I can now pre-package, right? Like if I'm building an MCP server, I might want to steal functionality from another MCP server. And so before that, I might have had to build like a proxy that lives in front of it. Now I can go get those tools. I can bundle them. I can sample, send those tools over. And so now I could have my own workflow that might need a mix of tools from other servers. And I believe I can sample them back over to an agent.
So where this goes, right, is what are you and I obsessed with from a product standpoint right now is like, great, if you have your MCP server set up, how do you remix them and progressively disclose tools in a way that is as respectful as possible of a context window, but still gets the job done. Right. And now all of a sudden we have a way to just send tools over and say, pick one so we can run it and invert the agent model. And so immediately, your head and then my head immediately went to, can we use this as a really innovative form of progressive tool disclosure? Can we actually show no tools on the MCP server except one, which when you engage it sends more tools over as part of this agentic loop? There's problems with that. The context isn't inherited, blah, blah, blah. We'll get to that. But that's interesting.
The context piece I think is interesting. So yes, the context isn't you don't inherit the context, but you've described one edge of the sword, but it is double-edged in the sense that you get a fresh context window on the client. And
So
so
it's an agent, like you were saying earlier.
yeah, so you get this opportunity. Like, look, there's obviously some more stuff to be built here. I think in the protocol, around the protocol at the moment, but there's a world where you can ship a single tool and somebody declares their intent to what they're trying to do. And then now you can dynamically select the tools that you want, go sample back with that dynamically generated set, and then let their agent actually go, run some program over it. And so I don't think that's the extreme that we're going to go to, right? The extreme today is you ship your entire universe in an MCP server. That's broken for all sorts of reasons. The other extreme, folks are doing either with a handful of like search tools and dynamically executed tools or whatever, or maybe through sampling with tools, which is you expose a handful of utility stuff, and then you just go throw as many dynamically generated things as possible. And I'm sure we're going to settle somewhere in the middle, as history probably tells us.
I mean, there's absolutely no reason that you couldn't design an MCP client that did, in fact, have a way to inherit the context that preceded this sampling. Like, I think we are so pilled right now by what happens on the server, because that's our domain with FastMCP, and we sort of take for granted what clients do, and we all know what the big clients are, and frankly, we're just consistently disappointed with the state of most clients. They don't support most features. Most of what we're talking about right now will not be supported by most clients, which is one of the reasons that we just keep trying to advance the FastMCP client and make it as good as possible in the hope that more and more people will use it, right? But if you build a client and control the client, you can actually do such crazy, interesting things with what we're talking about. And so it's occurring to me as you're describing this, that everything that we're talking about is true from the point of view of I have full control of the server, but I don't know the client or its capabilities is going to connect to it. So I sort of have to architect for the lowest common denominator, like the worst version of that client. That's what I'm going to be able to do. No context sharing, no. But if you build your own client, now all of a sudden the protocol is just the starting point for your ambition. And if you do want to bring in that context, or you do want to now do dynamic, like all kinds of interesting things become available. I don't even want to speculate about them because who knows what we'll do, but there's a whole world out there.
Any other SEPs we should talk about? I know you and I are both trying to wrap our head around SEP 1036.
Which is that the URL
elicitation mode. So like, I feel like I can describe the promise of it.
Me too. It sounds like such a good idea.
So elicitation is another one of these things like sampling, where there's a handful of clients. It's not widely adopted yet that support this, but fundamentally, elicitation is, while I'm trying to invoke a tool, I need more context from the user. And so I can send an elicitation request to the client, and MCP clients, when they receive an elicitation request, inside of their like chat window or what have you, are supposed to launch a form. And the form is like a nice typed form that determines like, okay, so here, go type all the extra information. So, I might have a tool that's like ordering a t-shirt. This is the usual example. And so I would elicit back and say, okay, what's the size of the t-shirt? So then Jeremiah would open it up and he would be, I don't know what your shirt size is, but you would type it in, you would hit enter, and then I would get that information. I can go complete the order. But let's say that Jeremiah is very sensitive about his t-shirt size, and he doesn't actually want to tell that to his chat window, right? He doesn't want OpenAI to actually know that information. So URL mode elicitation is, instead of sending over the form that Jeremiah has to fill out while his client is watching, the server sends over a URL, and the client takes Jeremiah and he sends him to this remote URL. He fills out that form in a way the client doesn't see. He hits send, something happens, and then the server then gets the information, is able to go around with it. And so the core idea is pretty simple. Sometimes MCP servers need access to information that the user needs to fill out. They couldn't know a priori. Elicitation up until this day means you have to fill it out in a way that your LLM sees. That's probably bad for some secure information. So how do you send somebody to a secure portal to input that information? So that's the promise of it. All right, Jeremiah. So you're an actual like maintainer of open source software. Talk to us about the owl.
Everything you just said sounds amazing. Like, and I wanted to use this, and I set off to be like, great, let's make this as easy as possible in FastMCP. And I called up the SEP and I look at how it's been implemented in the low-level SDK, and I was like shocked. I was like, oh my God, there's only 2 functions to call: one to start the elicitation, just like a normal elicitation, and one to complete the elicitation. And I was like, so presumably I start it, and then when it's done, I complete it. And no, that's not the case, because you mentioned earlier, something happens and the server gets the sensitive information. Well, that is a load-bearing something, because it turns out that's the entire hard part of this. We already had a way to send information to the client. Now it just happens that we're sending a URL. That's great. So now we have an entire new mechanism for saying it's a URL. It's not a JSON form. Great. And the protocol says that we no longer expect to get information back after we send that URL. That's great. But how do we get the information back to the server is left completely open. And it is, to me, I think I like sent this out in a tweet because I was like, didn't understand this. I was like, this is peak draw the rest of the effing owl. It's like, how is anyone supposed to know what the best practice is for doing this? And moreover, the obvious thing to me was, great, so we'll help people expose an HTTP route that they can receive information on. But then I'm wondering, well, wait a second, what if you have a standard in-out server? You don't have HTTP routes. Do I have to also implement, like, I don't know, a file watcher? Or do I have to like invent a new service that you're supposed to host that you ping? Or is there a secure way of doing this? How do I actually know that I'm getting a message from the person I sent the URL to? It all seems based on like a single little ID string. There's no handshake. It's like the questions explode. And it's one of these things where there is an answer, but there are many answers. So in other words, it's a solvable problem. The spec makes no claim. The entire thing I just went through is a dotted line in a flowchart that says information comes back or something like that. But the feature is useless, literally useless, if you don't implement that. And there's no best practice, there's no guidance, there's no transport agnostic way to do it. And so I think we may punt on this in FastMCP until a standard emerges or we decide to invent it. Because I am not the person who is an expert in drawing this kind of owl. And I don't know if we can be. And so this feels like a feature that is so good, so useful, so promising. We have multiple customers that we work with who would implement it immediately. But there needs to be a best practice open source mechanism for doing so. And the spec explicitly doesn't have it, which means the SDK explicitly won't have it, which means it has to be an application stack like us. And it's too open-ended for us to express an opinion at this time.
How are the low-level SDKs implementing it right now?
They're not. And so this is an interesting thing about this latest batch of SEPs, actually. Most of them require some form of infrastructure to work. Background tasks require background task infrastructure. The SDK has an in-memory one that it makes available for test cases. And all of the interfaces with that infrastructure are well described enough that anyone like us can come along and actually introduce a first-class one very easily. Tool calling, structured tool calling, 1577 we talked about a moment ago, requires a place to run those tools. That can be your server itself. The spec does not make any claim about how and where you run those tools, but it provides all of the hooks to know what the expectation is about what it means to run a tool. This one requires a giant question mark to get the information back in a secure way and provides absolutely no guidance on how that's meant to be done. And it's one of these things where you almost feel stupid asking the question like I am now, because the protocol is not going to answer it, because the protocol is making it clear that the protocol's job is to allow two parties, a client and a server, to have this interaction, not to specify how they do it. And that's fine. That's the protocol's right. And the SDK is going to implement it that way, which means the SDK doesn't implement this in a usable way at all. It's going to fall to application stack to implement it. But this is the only one where there is no guidance on the expectation there, which means every server is going to be different, which means security standards aren't there. I don't think this should have gone out, personally, without this guidance. I don't know. Maybe someone listening is like, no, there's an obvious way to do this, and that's great. Why isn't it in the spec?
Well, you can elicit them for an answer and then not get a way to send you.
I have no way to get the answer though.
There's one more that I mean, there's SEP 991, which, by the way, I assume you have all these SEP numbers memorized, right?
I have no idea what is
That
this
is the client ID metadata.
I'm excited about this.
I'm not a big auth expert. You spend more time thinking about auth than I have. Do you want to? What's CIMD mean to you?
I'm not going to pretend to be an auth expert. I think this is, I understand the value of this because I ran into problems with its predecessor, Dynamic Client Registration, DCR. Then because I have reasons that this is the best, I believe that it is. I'm happy whatever the spec represents. I'm happy to like take as the best version of given our understanding at the time. Dynamic Client Registration essentially had this problem, of being a very underutilized part of the OAuth spec. So when MCP showed up, I think you put it this way, right? It instantly and overnight became the sole and massive user of this part of the OAuth spec. That was kind of
yeah. I mean, DCR had been this thing that had been like spec'd out for a long time. It's just nobody picked it up, right? Like for folks that maybe I will cosplay as an auth expert for a second, right? But it's like when you do typical OAuth stuff, like you end up going over to your authorization server and you're like, hey, by the way, like here's who I am. I'm going to prove to you who I am. Like, can you send the credentials back here? And most of the time you have to pre-register where it can send credentials back to. Otherwise, like you can trick it to send credentials back to anywhere. So everybody who's ever set up an app before knows that you have to go set the allowed redirect URIs for all this type of stuff so that you don't accidentally, exfiltrate secrets to random folks that are listening. But dynamic client registration was born out of the idea of like, well, this Claude code session is going to want to use it, and then this Claude AI session is going to want to use it. This Chat GPT session is going to use it. And everybody has their own client that's trying to connect to it. So a priori, registering Jeremiah's ChatGPT instance and mine and my Claude code and our other team's Claude, like that just didn't seem like it was on the table. And so MCP solved this with, why don't you let clients go and dynamically register themselves so that they can walk away with those credentials? And so, but yeah, let's with the history of PCR. What's CIMD?
To quote Tobin South, who's a partner of ours over at WorkOS, who described this to me as, how did he put it? He was like, look, it's not anonymous DCR, but it is pseudonymous. It's like taking a ticket at a deli counter. You can take as many tickets as you want. You can have a mask when you take the ticket so no one knows who you are. You can fill the queue. It doesn't matter. But when you get to the front, if you have the ticket, it's your turn to speak, right? And so there's no need to like write your name or like prove that it's you or anything like that. You just show up, you register. You want to talk to the server again? Come register again. It might not even be the same client ID. It doesn't matter. You're just taking that ticket. And so this led to all kinds of problems of if you have a server where an auth server, not an MCP server, that supports DCR. And so what that means is anyone in the world, including me 4 times in a row, can go to that server and get a new client ID and then use that to prove my identity to an MCP server that is linked to this. There's this interesting thing where, for reasons I don't fully understand, and I'm not going to pretend that I understand auth, I'm sure there are like reasons for this, but like the way it actually works out in practice is if I know your DCR auth server, I can register with it and I can go over to any other MCP server that also uses this as a registration point and talk to it because it has no way of actually knowing who I am. And so you get in this implicit best practice situation of, well, you can only have one MCP server for each DCR sort of domain, but this is not actually enforceable because the whole way dynamic client registration works is since I don't need a secret piece of information to prove that I'm the server that was registered there, anyone can register to it and anyone can respect those tokens if they choose to. There's no shared secret. And so I think this is sort of the crux of the problem is that because there's no shared secret, you can't actually affirm who anyone is. It's this pseudonymous setup where you know people are using your server. You don't know who, you don't know unique, you have no way to restrict. And I think that became problematic. And so I think now we're moving to a world where, as I understand it, this is optional, this is not required, and DCR remains part of the spec, so I don't think it's being like forcibly removed. But now clients can advertise who they are with a securely hosted bit of ID metadata, which allows a more consistent like identity across servers, across time. I don't recall the details right now on how that handshake takes place, except that I think it solves part of the pseudonymous part of this. I hope I'm pronouncing
And how surprised are you that WorkOS already supports it?
And zero surprise. Of course.
Yeah, this was our unaffiliated commercial for Tobin and the team at WorkOS.
Yeah, 100%.
All right, that's all I got.
Those are the SEPs. I mean, there's others. It's a pretty packed release. I know as we're recording this, I know a lot of the SDKs are rushing to comply with the release. The release came out 1 week ago. The SDKs must be compliant a week from now as we're recording this. I know from FastMCP's point of view, main branch is getting crowded. We will be shipping our first 11.25 updates early next week, which I'm super excited about. And background tasks will be the headline for us. Tool sampling will follow when the SDK fully supports it. Those are the major ones we're looking at.
Scrolling through the list here, I think we hit pretty much.
There's like the headlines.
We hit the headlines. Like there's some stuff about like there's some back of house enterprisey stuff of like how it connects to your IDP, and then there's some stuff about like the registry, some stuff about MCP bundles being officially like replacing DXT. I think DXT was a side hustle, not. You know what I mean? Like it wasn't part of the spec. It was like a nice quality of life installer for MCP servers, and now there is an official installer for MCP servers locally.
There was one that I reviewed because we just added FastMCP where it's official tool name validation.
Oh yeah.
Little nice to have because
SEP 986.
Okay, 986. There we go. I think it's a little nice to have. We're actually being more aggressive than the SDK. Are we? Now that I've said that, I don't remember. We have some places where we're being more aggressive than the SDK and actually failing your build. Whereas I think the SDK just like sends you a warning when you list tools on this one, which is, to be clear, what the spec says. We're being more aggressive. And the reason is it turns out that a lot of clients already implement restrictions. So if I'm remembering right, Claude Desktop doesn't let you use a colon in a tool name. It'll freak out at you. And so that's a quick way to get into trouble. I don't think we ever went so far as to stop that, but I do think for some of our server composition prefixing stuff, we had to take this into account because we were using colons as a natural delimiter. So I actually like this as a declaration. It's just a standard way of doing this. I like that. There's another one I like. Maybe you can find the number that has to do with enums in Elicitation, back in like normal Elicitation, where you can have a multi-choice now, which it's a tiny little thing, but this would be like, instead of choosing your t-shirt size, you can choose multiple sizes and send that over. Tiny little quality of life thing, but I
don't think I found that one.
But that SEP, whatever it is like, again, very minor, very useful. And it's increasingly, folks are building applications on top of MCP. I think these are the sort of things that are going to start to matter. Next time, we need to talk about MCP UI. Speaking of which, because now there's a the protocol. Now there's a part of the protocol to talk about official extensions of the protocol. Yeah, exactly. We need to spend some time digging in on that. I don't think we have time to do justice today.
Cool. All right. Well, we can talk about MCP UI and extensions of MCP. Maybe talk about what we want to see as extensions of this. I don't have favorite extensions of it yet, but MCP UI is definitely a pretty cool one for now.
Definitely on the list, yeah. Well, this is great. I'm glad we got to go run through some of this stuff, the good, the bad, the confusing.
I learned a lot about different Septembers of in history. SEP 986, September 986.
What happened?
It's when King Harold II, aka the Bluetooth King of Denmark, died.
Oh wait, so, I know what this is because of Bluetooth, because I've heard the story.
And that's all I got. I forgot all the other ones as I looked at. September 1686, of course, when the Habsburgs captured Budapest from the Ottomans. Of
course, and anyone who wants a crash course in that should go find Adam's talk that's somewhere floating on the internet now, where he goes over, yes, background tasks, but more importantly, what happened in September of 1686.
SEP 1577, the Treaty of Bergerac. I just assume,
Of course.
everybody should know this stuff.
Of course.
All right. Well, we'll catch you next time, everybody.
Take care.
See ya.